what transformations really are, just like how your graph has changed from your parent function. So thinking about back to what you know in Algebra 1, your linear graphs, that's what you dealt with. Think about that linear graph, that parent function. If you go to your first example, that's just that line y equals x, right? There's no slope, the y-intercept, or by no slope, I mean the slope is 1, the y-intercept is 0. So thinking about what you know from there, kind of your parent function is where there's no transformations, in the sense it's like the original graph. So let's check out the conclusions, that last page. So how did the graph of the function shift when a number was added or subtracted outside the parentheses? So kind of looking up that column, does anybody want to share what they noticed? Yep, Parag, what'd you notice? Cool, so that's a good conclusion. The y-intercept was changing. So think about how is that shifting your graph if your y-intercept is changing? Up or down. So thinking about our transformations, we're talking about outside the parentheses. So let's look at these two first. So while you guys are filling in on your notes. So when you were adding a value, how did that shift your graph? It went where? Up. So when you're adding outside of that parentheses, it's going to shift up. And it would shift up however many units. So in this example, we're shifting up k for however many units. But looking at your example here with that linear, when you have f of x plus 1, notice your new y-intercept is 1. It went up 1. What about if you're subtracting outside? Yeah, shift down. All right, good. So think about that outside that parentheses. That's if you're going to go up or down. So now let's talk about how is the function shifted when a number was added or subtracted inside the parentheses. What did you guys notice? What did you notice, Nick?
If you added a number, then the function is for left, and then if you subtracted it.
Good. So like inside here, if you're adding, you went to the lefty side. So we'll shift left h units. And then when you said you're subtracting, you're shifted to the right. So I kind of always remember, if you're thinking about a coordinate plane in general, thinking about if all of your positive values are on the right and all your negative values are on the left. So I kind of always remember insiders lie. So you kind of, if you see a plus, you kind of want to intuitively think you're going to go to the positive, but you're actually going to be shifting left towards those negative values. So if that helps you, take that to help you. All right, so our next column. So how did the graph change when a negative was put in front of f of x? So that'll be for down here. So when we had a negative in front of our f of x, in front of our function, what did you guys notice? How did that graph change? What did you read?
The graph would flip across the x-axis.
Good. So flip or reflect across your x-axis. So reflect over your x-axis. So remember, like your f of x, that's like your y. So think about what this is really saying is your y value is becoming negative, which think about here, if you had a positive y, and then you flipped over to be negative, you'd be down here, flipping over your x. And then, what about how did the graph change when a negative was placed in front of the x inside the parentheses? So anybody notice any changes there? What did you notice, Nick?
It flips over the y.
Good, so reflecting over the y-axis here. So we'll look at some examples of reflecting over the y-axis today. Just know we're mostly going to be dealing with reflecting over your x-axis while we're in Algebra 2. And then how did it change when a number was multiplied in front of the function? So let's talk about what did you notice when your a was between 0 and 1? What did you guys notice? How did that graph change? It doesn't have to be in super technical terms, just how did you notice it kind of change? You helped us out a lot today. Anybody else think about how did that change when it was having a value between 0 and 1? Just what do you notice? Yep, what do you notice? Perfect. So it got narrow or like kind of flatter, right? So which one did it become more narrow, like skinnier? Like which of these? When it was bigger than 1 or between 0 and 1? Okay, good. So kind of know that that's when it became more narrow or like more skinny. So thinking about what we call that, we're going to call that a vertical stretch. And it'll be by vertical stretch by whatever your A value is. So kind of think about if you have that, okay, so let's look at that quadratic graph. So that's on the back here, it's the U one, it's the one in the middle. So notice all the way at the end it had 2 times your function. So when you're thinking about vertical stretch, if it helps you, kind of think, if I took the top of that graph from the top, so vertical stretch would mean I'm pulling it up. So I'm pulling it up so it's becoming skinnier. That's what it means by that vertical stretch. I'm taking from the top and I'm pulling it up. So it's getting to that idea like getting skinnier. And then we also said this one became like more flat. So what we call that is being a vertical compression. And that'll be by factor A. So thinking about with the stretch, I took it from the top and I stretched it up. So if it's vertical compress, I'm taking it from the top and I'm compressing it down and making it more flat. So that's kind of like the idea behind that one. With those two, if it helps you, kind of think those are kind of like your ideas of only the linear functions have slope, but those are like where your ideas of like slope would be coming in, making that line more steep or more flat. All right, so we're going to kind of use this for the rest of our class. So these are all of our transformations we are going to be dealing with. So let's look at some problems with it. So we kind of have where we'll be looking at graphs and figuring out what transformations happen, or we're going to be taking it from an equation. So thinking about taking it from the equation, think about always going like left to right. So you just kind of start all the way to the left and move to the right and figure them all out. So if I'm starting all the way to the left here with number 1, what's our first thing we see? A negative out in front. What transformation was having a negative out in front? Yeah, good. So reflect over the x-axis. Now, here, I'll do it in colors. Now I have that minus 2 inside the parentheses. So who can, with a hand, help us and tell us how does that shift your graph? How does that shift it, CJ?
It's a shift to the right.
Right by how many?
By 2.
Good. So I'm going to go right to here. And then lastly, I have the plus 5 all the way outside the parentheses. Thanks, I know what that one can remind us. What do you think, Nate? Awesome. Up by 5. So we're going to check out number 4 together, and then you guys can try 2 and 3 on your own in a second. So looking at number 4, what do you kind of already notice about the transformation that might be happening in number 4? It's a negative x, right? So that negative x, remember, that's going to be reflecting over your y. So when you have that reflecting over your y, and you also have another value inside, you're going to want to take a second and factor out that -1 in front of your x. So let's see why. So if we take a second and factor out that -1, we would just have x minus 3 and then plus 11. So if I'm just, so we said we'll reflect over our y-axis. So if I'm looking back at my original problem, what do I think is going to be happening with that plus 3? I would go where? Left 3. But what's actually really happening? Where are you really going? You're really going right 3. So that's why you want to take a second and factor out that -1, because we're really going right 3, and then we're also going where? Good, up 11. So let's do number 5 together, and then you guys can try the rest of the page on your own. So checking out number 5, we are going to first state the transformations and then write the equation. So who notices one transformation that's happening here? What's one thing you notice? What's one thing you notice, Grace? Good, so I reflect over the x-axis. And we got one more. What's another thing you notice? Yep. Up how many? 2. Good. So now we're going to write a transformation that describes that. So I'm going to use, my parent function is f of x. So I'm going to use that f of x notation to write the equation for what's happening. So if I reflect with over my x-axis, how do I show that in an equation? Negative in front of that f. Good. And then if I'm going up 2, how do I show that? Good. Plus 2 outside. All right. So why don't you guys try and work on the rest of this page? Why don't you guys try the graphs? Write down the transformations and then try and do it. Actually, let's do this one together here, the last one on the page, because that one has the stretch, so it'll be a little, okay. So we'll do that last one together, and then you guys can try the rest of your page on your own. So we have our original parent function, our absolute value function. So let's think about all the things we have going on. So all the transformations we have going on. So this negative out in front means I'm going to do what? The negative means we'll reflect over your x. And then the 2 means you'll do what? Stretch. Stretch by 2. And then this plus 1 inside means I'll shift. Left 1, and then the minus 2 outside means I'll go down 1. Sorry, down 2, my bad. So we have 4 different things we want to try and express here. So thinking about doing all this, kind of think about taking this minimum point here to kind of help guide you. So I have to reflect over my x-axis, so kind of thinking that's what that first transformation would look like. We're not done yet, so then think I have to stretch by 2. So stretching by 2 means, see how if I'm at my minimum point, to get to my next perfect point, I just went down 1 and then left and right 1 in both directions. So to get that stretch of 2 idea, instead of going down 1, it's kind of like your slope. You're going to go down 2, and then over, left and right, 1. So if I keep going down 2 and then over, left and right, 1. So that's kind of like our second step there. You don't have to, if you can do it all in one step, that's great. I'm just doing this to kind of show you guys the progression. And then we'll also have to go left 1. So think about this minimum point, we'll go left 1, and then we also go down 2. So left 1, down 1, 2. So then think about this green one is my final. We're going 1, 2, over again. So if you just want to show that green one, that's fine. I'll just erase these so it doesn't get confusing. So you guys take a second and then work on the rest of that page, and then we'll come back and see what questions you might have from it. So I'll have -3 f of, I'm going to factor out that -1, and then we'll have x and then +4 inside those parentheses. So one question I got was, because I factored out this -1, does that mean this now 3 should become negative? So no, kind of think that this is going to stay like separate from out there. I kind of can't jump over that f, that function. So from here, let's kind of look and think about all this transformation. So this, I have 4 spaces, so think about I have 4 transformations. So my first one's happening from this negative all the way up front, which means I'm doing what? Yeah, reflect x. And then my next one is going to come from the 3 out in front, which means I'm doing what? Yes. Stretch by 3. And then, what about the minus, the negative inside? Yeah. So reflect your y-axis, and then, yeah. Awesome. So what other questions do you have as you've started this page? Are there any other questions we want to go over? Yes. Got it. Let's see. All right, why don't you guys keep working on it? So you're doing a good job working. So keep up working on this page, and then let's just check back in like 10 minutes. So once again, finishing this whole packet is your homework. So if you finish this page early, don't just sit and chill. Just keep going through, because that's just like you getting your homework done. Alright, so we're going to go over number 7 on this page, so we can also go over any other ones that you guys are having any questions about. It seems like we're getting a good hang of it. So let's talk about number 7. What are some of our transformations we have with number 7? Yes, Russ. So we reflect over the x-axis, and what else do we do? What else do we do, Callie? And then what's our last one? Yep, up to. So what I want to talk about is kind of the idea of how you find your stretch. So this is an absolute value graph, and if you kind of think from the parent function, if I go to that minimum point, and I can kind of go up 1, right 1, up 1, right 1, or up 1, left 1, kind of in all those directions. That's like your idea thinking about if I'm going up, over, that's your idea kind of thinking back from algebra 1, like your slope. So kind of think about when you're finding your stretch or your compression, kind of think about it like your slope. So here, if I start at that minimum point, and I'm going to just put a good place markers on those next good points that go through the grid, I'm going down 1, 2, 3, and then over 1. So think if I went down 3, that'd be -3, right? And then over 1. So remember, the negative is already taken care of here by my reflecting. So just this idea of 3 is my stretch. Do we have any other questions from this page that you guys want to go over? Any other questions at all? Okay, so let's move to the next. Not on this page, but if you go to one more over, this number 26. So number 26, let's talk about what are the transformations we have with number 26. What are the transformations we have? Compressed by 1/2. What else do we have? Left 1. So I know I go left 1, I go down 3, and I'm going to compress by 1/2. So those are my 3 things I should be doing. So a lot of you guys have been asking about the order. It doesn't really matter as long as you can kind of get it all done, whatever works best for you. I like kind of thinking about taking that kind of a good solid middle point, moving it wherever I need to, and then making the either like reflections or your compressions. So I'm going to go left 1, and I'm also going to go down 3. So that's my new good point. So you guys should have at least 3 good points on your graph. Just 3 is good. That's all you really need. So thinking about this quadratic, kind of to get to your next points, when there's no transformation, you kind of went up 1 and then over 1 in both directions. So if I'm compressing by 1/2, I'm going to go up 1 and then over how many? 2. Good. So I'm going to go up 1 over 1. 2, up 1 over 1, 2. And once again, it doesn't have to be super perfect. You shouldn't keep going up 1 over 2 because it's a quadratic graph. So just get those 3 points and then kind of just draw the shape from there. Any other questions from the last page or this page as you guys have been working that you want to go over with the class? Right, so just so everyone's clear, you should be finishing this for homework, and then if you guys could go through to the very last page, see questions 15 through 17. The very last page, but like this is the last page, but it's on this side. So 15 through 17, the question says state the function family, write the equation of the transfer function, and identify the domain and range. So you don't have to state the function family because we're not going over that this year. Right now, we're kind of go over it throughout the year. So when you're writing the equation, it should just be in that f of x formation that we've talked about and that you've seen. So just know you're just writing that equation with like the f of x, and then you're just identifying the domain and range. Bless you. Does that make sense? Okay, so you guys have the rest of the time to work, which is solid 20 minutes. So you should be able to get a good chunk of this done, and then remember, this is due next time, finishing this whole packet. What else is also due next time? Yeah, the review guide. So keep that in mind. And then, so that's just really all your quizzes on is these transformations and the graphical characteristics. Next time, we'll do a little bit of a review, answer questions you might have from your review guides and your homework, and that's it. Yes, Megan? No, so you are keeping that, and I stamped your assignment sheet. You're also keeping that too. So if you lose your assignment sheet, that's you losing your homework grade for the unit. So very important to keep that. And if you're someone that would like it hole punched, I have a hole puncher right here on my desk if you would like to come and grab it and use it too. Yep, Bogdan. Yeah, what's up?
Do we put in relation to zero?
Me what?
How do we find the effect?
Oh, okay, so let's do one together. So if you're at 15 through 17, so you're writing that equation, you're not saying, you're not stating the function family, you're just writing that equation, so in that f of x form. So what we mean by that is your original, kind of think, your original is always going to start like at 0, 0. So then think about how was this graph changed? What transformations did we have if we're looking at 50? Think about you moved from that 0, 0 point all the way down here. So it's one transformation you have. Get Robbie? Left 3. So I went left 3. What else did we do? Down 5. And what's... Yes, stretch by 2. You can tell us if you want to go to your next point, you had to go up 2 over 1. So I'm going to have a stretch by 2. So think about I'm going to try and show all those 3 things with that f of x. So if I'm showing stretch by 2, where should that go? The 2 out in front. If I'm going left 3, what am I going to show inside my parentheses? Plus 3. And then if I'm showing down 5, it'll be up. So let's do a little review. What's our domain here? Yes, negative infinity to positive infinity. And then what's your range? Negative 5 with a what? Yeah, negative 5 with a bracket to infinity.